Good morning, my dear students. It gives me great pleasure to talk to a student through video presentations like this as usual. In this particular video presentation, we will continue with some more concepts related to set theory of class 11 of CBSE. I am planning to add more videos for class 11 of CBSE. Those who want to have automatic notification about the new videos being uploaded, please subscribe by clicking the subscribe button as well as the bell icon. Okay, the concept which we are going to start with today is universal set. If we are going to think about a particular context, the very big set which we can imagine of containing all possible sets in that context is supposed to be known as the universal set. For example, if we are going to think about a competition held between the students of a particular school, let us say, according to the severity of the question given there, according to the severity of the competition, you can include all students of class 12 to be universal set. Or if you feel even 11th can join, you can even think of universal set to be set of all students of 11 and 12 in the same school. Or if you feel you can even include students from 9 to 12. For students from 9th standard to 12th standard of the same school can be included. Or if the principal tells you, you can even include students from other schools also. Therefore, all the students of CBSE in the city from 9 to 12 can be taken for granted as a universal set. Therefore, universal set is only our option. I repeat, in a particular context, the very big set we can imagine of to contain all possible sets in that particular context is known as the universal set. Okay, now another thing, if you are given two sets A and B, okay, by A union B, we call it as A union B. We mean, what is the definition? A union B is equal to set of all x or z, x element of A or x element of B or x element of both. If it is there in one of them, it will be there in the union. For example, if A has, let us say, 1, 2, 3, B has, let us say, 3, 4, 5, my A union B will be automatically 1, 2, 3, 4, 5. If it is there in one of them, it will be there automatically in the union. The common element is written only once as per the definition of the function, definition of a set. Okay, any element is written only once. Therefore, 1, 2 are there in A. Therefore, I will write 1, 2. 3 is there in both. 3 is written only once. 4, 5 are there only in B. Therefore, I will write 1, 2, 3, 4, 5. I will write 1, 2, 3, 4, 5. That is my A union B. Okay, by A intersection B, I mean set of all x or z, x element of A and x element of B. The common elements are taken down and written. Therefore, in the previous example, A intersection B is nothing but 3. Only the common elements are taken down and written. That is called intersection. I mean, I'll explain once again. Okay, if it is there in one of them, it will be there in the union. If it is there in both, it will be there in the intersection. This is the symbol to represent union. This is the symbol to represent intersection. This is the symbol to represent intersection. Okay. Okay. If intersection of two sets is empty, those two sets are said to be, if A intersection B is equal to empty, A, B are said to be disjoint sets or mutually exclusive sets. Mutually exclusive, disjoint, either way you can explain, or you call it as mutually exclusive. If the intersection is empty, they are said to be disjoint. You can think of an example also. Okay, I mean to say A has elements 1, 3, 5. B has elements 2, 4, 6, let us say. Here A intersection B is equal to empty. Therefore, A comma B are disjoint. They both are disjoint. These are odd numbers, these are even numbers. Any number has to be either odd or even. It can be, it can never be both. For here intersection is empty. Therefore, they are disjoint. They are disjoint sets. Okay, they are disjoint sets. Okay, now by A minus B set of all Ax such that X element of A but X not in B. That is, I'll take down all the elements in A other than the common elements. If we take an example, you will be able to write. You will be able to understand what it says. It is 3, 4, 5, 6. Therefore, by A minus B, all the elements in A other than the common elements. Therefore, it is 1, 2. B minus A will be 5, 6. 3, 4 is common for both. Therefore, all the elements, the first set other than the common element is nothing but the subtraction A minus B. I mean to say 1, 2. 3, 4 shouldn't be written. Similarly, B minus A will be 5, 6. Okay, A minus B, B minus A. This is how it is being explained. Okay, and if you are given a universal set U, and if you are going to think about the subset A of it, okay, A dash or A complement, you mean set of all X Z, X in U, but X not in A. Therefore, by definition, A dash is nothing but U minus A. All the elements in U other than the elements in A is called A dash, or we call it as A complement. We call it as A complement. We can take an example here. A has, let us say, 1, 2, 3, 4, 5, 6. Okay, then my A is nothing but 1, 2, 3. A is nothing but 1, 2, 3. Okay, my A dash will be automatically 4, 5, 6. All the elements in U other than A is called A dash. It is called A dash. Okay. Therefore, I have explained union, I have explained intersection, I have explained A minus B, I have explained a complement, I have explained A dash, okay, and I have explained disjoint sets. Okay, if I am able to express sets using circles and squares or rectangles, etc., such a representation is known as Venn diagrammatic representation. Okay, Venn diagrammatic representation. Just listen carefully. A union B. This is A union B. If it is there in one of them, it will be there. Therefore, this is the representation for A union B. Okay, now this is A, this is B. Only the common elements are shaded. This is representation for A intersection B. This is A and B. This is the representation to show that A intersection B is empty. Okay, then this is the this is my universal set, this is my A. For other than A, I should shade everything. For this is the representation for A dash. This is the representation for A dash. I repeat, leftmost circle tells you set A, rightmost circle tells you set B. If it is there in one of them, it will be there in the union. I already told you. Therefore, this is the representation for A union B. The common element should be shaded, common portion should be shaded. This is the representation for A intersection B. This is the representation to show two disjoints. I'll draw two non-intersecting circles and I'll draw A, and around that I'll draw universal set. All the elements in other than A, therefore this is the representation for A dash. Okay, this is the representation for A dash. Okay, I think some more results we'll discuss in the next video. I don't think there is any correction. I'll just go through anyway. Thank you students for patient watching.